Cosmic Radio Show, The Mystery of Time Travel. Welcome to the Cosmic Radio Show, where we dive deep into the universe's biggest mysteries, explore cutting-edge science, and venture into the realms of the unknown. I'm your host, Asher Knight, and today we're talking about a mind-bending concept that has captivated scientists, philosophers, and storytellers alike: time travel. What is time travel? Time travel, the ability to move forward or backward through time, is a staple of science fiction, but it's also a topic explored seriously in theoretical physics. Imagine stepping into a machine that could take you to the distant future or back to ancient times. But is this just fantasy, or does science provide a framework for making it possible? Einstein's theory of relativity. To understand time travel, we need to start with Albert Einstein's groundbreaking work on relativity. According to his theories, time isn't a fixed, unchanging entity. Instead, it's part of what physicists call spacetime, a fabric that can bend, stretch, and even warp under certain conditions. Traveling to the future, high speeds and time dilation. Let's talk about traveling to the future. According to Einstein's special theory of relativity, time dilation occurs when you move at speeds close to the speed of light. Imagine being on a spaceship that travels at nearly light speed. Time for you would pass more slowly compared to someone back on Earth. Here's a simple example: if you traveled at near light speeds for just a few years from your perspective, decades or even centuries could pass on Earth. This is time travel to the future in action, and it's been confirmed experimentally with particles and even atomic clocks on high-speed jets. Gravitational time dilation, the power of gravity. Now, what about gravity's effect on time? Einstein's general theory of relativity shows us that time passes more slowly in stronger gravitational fields. For instance, if you were standing near a neutron star, a celestial body with an incredibly powerful gravitational pull, time for you would tick more slowly than for someone far from that star. This effect was famously depicted in the movie Interstellar, where astronauts experienced extreme time dilation near a massive black hole. So, time travel to the future isn't just theoretical, it's real and supported by our current understanding of physics. The challenge of traveling to the past. But what about traveling to the past? This is where things get tricky and controversial. Some solutions within general relativity suggest it might be possible. These include concepts like rotating black holes, known as Kerr black holes, and wormholes, hypothetical tunnels that connect distant points in spacetime. These ideas sound fascinating, but they require conditions we've never observed in the universe, such as exotic matter with negative energy. Even if these logical problems. The grandfather paradox. One famous paradox is the grandfather paradox. Imagine you travel back in time and prevent your grandfather from meeting your grandmother. This would mean you were never born, but if you were never born, how could you have traveled back in time to begin with? The logical loop creates a contradiction that's hard to resolve. The chronology protection conjecture. The late theoretical physicist Stephen Hawking proposed what he called the chronology protection conjecture. He suggested that the laws of physics themselves might prevent backward time travel to avoid these paradoxes. In other words, nature could have built-in safeguards to keep causality intact. A journey through possibility and imagination. While time travel to the past remains speculative, the idea fuels imagination and creativity. Science fiction often explores the consequences of changing the past or witnessing historical events firsthand. Even if practical time travel isn't possible, understanding time as a flexible, dynamic part of spacetime changes how we think about the universe, and our place within it. Final thoughts. Time travel is one of those concepts that challenges not just our understanding of physics but our sense of reality itself. Whether we ever build a time machine or not, the theories behind time travel remind us just how strange and fascinating the universe can be. Thank you for tuning in to Cosmic Radio Show. If you enjoyed today's episode, don't forget to subscribe and share it with your fellow time travel enthusiasts. Until next time, stay curious and keep exploring the cosmos. Take care, and maybe, just maybe, we'll see you in the future.